let's take a look at what I did wrong first off. Do you see what's wrong up there? Well, here, rather than saying what's wrong, here, let me just do it correct. So this is a correction. Yeah, so 3 beakers. And remember, in the bottom go the dollars or the percentage. In this case, it's the dollars. And so first off, we have the cashews. And those are $4 a pound. And we have the peanuts, which are $1.50 a pound. And then the mix. Over here's the mix, right? This is the cashews. Cashews, peanuts. And the mix is what, $2 a pound. So remember this problem, we're mixing some more expensive nuts and some cheaper nuts, right? Some more expensive cashews and some cheaper peanuts to get a mixture that's in between price, right? $2 is in between $1.50 and $4, right? So it's going to be mostly peanuts, isn't it? Because it's, it's closer to the peanut price than it is to the cashew price. The mix is $2, pretty close to the peanut price. So it must be mostly peanuts. Anyway, how I messed up is I didn't look closely at that 80. I popped the 80 over here. That's not where it goes. Because the 80 is not the total amount of the mix in the end. That's what they usually do on these problems, and I was just assuming. Yeah, what's the 80? It's peanuts. Yeah, the 80 goes here. I didn't read it careful, and none of you helped me out. You're supposed to be helping me out. Right? I do that kind of stuff all the time, but normally somebody says something. All right, so be on your alert today. I'll lay little traps of wrongness as we go. I don't know, maybe not. Make sure you're alert. All right, 80 pounds of peanuts, so it goes right there. It's not the total mix amount, so which is often what they do. Anyway, so then this is cashews, call it C. Well, then what do we put over here? C plus 80. Because, right, cashews plus 80 must be the total amount of the mix. That makes sense on that one? See how I'm coming up with that? Right? Because amount of cashews plus amount of peanuts, which is 80, must be the total amount of the mix. Cashews plus 80, that's the total amount of pounds of the mix. However many cashew pounds plus 80 pounds is the total amount of the mix pounds, right? All right, now notice I only have one letter. Now, doing it this way, there's no P. There's just C. So if you only have one letter, you only need one equation, don't you? Where do I get that equation? I don't even need to do the first two. Remember the first equation I always said is the top, but that's going to be meaningless. That's going to be C plus 80 is C plus 80. That does nothing for me. Of course that's true, but it's not helpful, right? But step two, equation 2, that comes from multiplying. That's the one we need. Multiply 4 times C, multiply 150 times 8 equals multiply 2 times C plus 80. So there's your equation. Solve that. It's only got one letter. Just so distribute here, right? 2C plus 160, 4C. Did I do something bad again? Oh, 80. Yeah, there we go. That's like 120. And then just solve. First, yeah, I think it's 2C is 40. I think C is 20. So there we go. C is 20. 20 pounds of cashews, at least for my numbers. All right, so there's the correction. Okay, so we talked about matrices, which are numbers in boxes, and they made them up to do things in real life that they were helpful. They are helpful. They're used in all kinds of things in real life. But they had to make up rules for them. So whenever they make up something in math, they make up how you're going to add those things, subtract those things, multiply those things, divide those things. So they made up some rules for how and we did the adding already, right? Remember what we concluded yesterday? We said, if you wanted to add matrix A, we're not adding on this problem, but suppose we did. Suppose we wanted to add matrix A and B. You know how to do it, right? How would I add A and B? Yeah, entry by entry, corresponding numbers, right? Like the 0 and the 6 would just add. And the 6 and the 1 would just add. And the -2 and the 0 would, etc. Right? That was really easy. That's how you and I would have made it up, huh? What if we wanted to add matrix A and matrix C? which are, notice, different sizes. Yeah, we say don't do that. Do not do it. Do not do that. Right? You cannot add or subtract different sized matrices. They just never made up a rule for that because it was never important. It never had a real life use of any kind. So they didn't make anything up. They just said don't do that. Why would you ever want to add different sized matrices? That's silly. So that they skipped. Well, now we want to go on to how do you multiply? So we're taking matrix A times matrix C, right? AC here. They want me to multiply matrix A times matrix C, which, again, are different size matrices. We can't add them. We can't subtract them. But can we multiply different size matrices? Sometimes we can. Let's talk about the rules first off. When can we? When you multiply. So what I'm going to do is I'm going to give you the by hand rules, and then we're going to also do it on a calculator. So we'll do both ways. When you multiply matrices, here's what you do. Number one, take the size times the size. So notice, what's the size of matrix A? A is a what by what? Look at matrix A there. Remember, when you do the size of a matrix, it's the opposite of graphing. It's down first, then across. So it's a 2 by 3. It's a 2 by 3 matrix. Making sense so far? Times, and then what's B? Well, not B. I'm supposed to do C. C is a 3 by 2. Down 3, right? Size is always down by across. Down by across. Like that. All right? Now, it's okay to multiply if the inside numbers are equal, meaning this number and this number. They're equal, so then that's okay. It's a weird rule, huh? Remember, they made this up. I would be asking, why did they make that up? That's weird. We'll see. It actually is useful this way. So if the inside numbers match, then it's okay. And the size of the answer matrix will be the two outside numbers. In other words, the size of the answer matrix will be 2. Whoops, I circled the wrong one. That was a mistake. The size of the answer matrix will be size of the answer 2 by 2. These two numbers. That's why they're giving me a 2 by 2 setup for the answer. Because the answer matrix is going to be a 2 by 2. So did you follow all that? You write down the sizes of the two matrix. The inside numbers have to be equal. And if it is, you can do it. And the answer matrix will be the two outside numbers. That's how we do it. So let me ask you a question before we so this, I've just told you we can do it, and the size of the answer will be a 2 by 2, which, of course, you could have told just by the picture. So could we, before we go further with this, could we multiply matrix A times B? Is that even possible?
A times B?
Yeah, what if they'd asked me to do A times B? Could I? What's the size of matrix A?
2 by 2.
It's a 2 by 3, and B is a 2 by 3. So this is 2 by 3. This is 2 by 3. Do the inside numbers match? No go. In other words, you can't even multiply, at least in this case, the same size matrices aren't allowed. But some different sizes are. This is a weird rule, isn't it? Couldn't multiply A times B. But you can multiply A times C, and the answer will be a 2 by 2. All right, get that copied down. I'm going to go to a fresh screen here. And so let's do A. So how do you do it then? So we're going to do it. A times, let me write A down here, 0, 6, negative 2, 1, 1, 5. That's A, and then here's C, 4, 2, negative 6, 1, 2, 2. All right, we're going to do A times C. We know it's going to be a big 2 by 2, so I'll put in the blanks already. It's nice to know the size of the answer matrix as you begin, right? It's a 2 by 3 times a 3 by 2. The insides are equal, the outside 2 by 2. So this is a 2 by 2. So, all right, how do you do it? Well, basically, I'm going to show you by hand, then we'll do by calculator. Your left hand always goes across, your right hand always goes, kind of like that old joke, can you pat your head and rub your belly? You know, you got your different hands going different ways. The left hand's always going across, and the right hand's always going down. That's how they made this happen. So you take your left hand, you go across, and your right hand you go down, and you jump with every multiply. I mean, you skip to the next one with every multiply. So 0 times 4. 0 times 4. Plus, and then you jump. 6 times 2. See what I'm doing? I'm going across with my left hand and down with my right. 6 times 2. It's going to be 12. Yeah, I'll figure the answers out in a minute. I just want to write it down so you'll see the steps. I probably didn't leave enough room. Keep going, and then negative 2 times negative 6. And whatever that is, what's that number? 12 plus 12. Isn't that 24? Because it's 12 plus 12. That's the upper left-hand corner. That's one of the 4 numbers in the answer matrix. Yeah, because I went across the top row, down the first column. So that was upper left. Upper left. Let's try the next one. Now, come lower left. I'm going to use the left again, and I'm going to get this lower left answer. Everybody see that? I'm going across, and I'm going down. Lower left. So here we go. 1 times 4 plus 1 times 2 plus 5 times minus 6. Minus 6. So what's that? 8 minus 30 minus 22? Lower left. See how I'm doing that? Is this making sense? My left hand is going across. My right hand is going down. So you always start on the left edge, either the left edge on the top or the left edge on the bottom, and you always start at the top on the matrix on the right. Now, so I've done both the left entries. Now let's go over to the right side and start again at the top. Everybody see where I'm at now? I'm trying to get the upper right answer. Upper right, I'm doing upper instead of lower. Oops. Come on. And right instead of left. Upper right. Here we go. 0 times 1 plus 6 times 2. See, my left hand's going across, right hand's going down. 6 times 2. And then negative 2 times 2. So what is that? 12 minus 4, 8. Upper right is 8. Good to there. And finally, yeah.
Shouldn't the other bottom one be negative 24?
Yeah,
30 minus 6.
30 minus 6.
Yeah. Thank you. Thank you. You guys are looking today, huh? That's right. It's good. I do a big goof up every now and then. You guys will be alert. Thank you. All right. So now let's come over here. Lower right. Lower right. So 1 times 1 is 1. Well, I'll just write it out. And then 1 times 2. You see where I'm going? And then 5 times 2. So what's that? 2, 3, and 10, 13. And there we go. Does that make sense? There it is. It's a big pain, isn't it? Multiply matrices. Shall we do it on the calculator? So let's do it on the calculator. So I'll write the steps down. If you've got all that down, I'll erase some of this. I'll write the steps. Basically, it's simply this. Enter A, enter C to your calculator, and then go on the main screen and go call them for the inner matrix A. You remember the edit mode? Remember how to enter a matrix? You go, let me go through the steps again. So first off, you have to enter matrix A, and that means go second matrix and go across twice to the edit mode. And then step 3, you what do? You enter the data. And step 4, you second quit. So that's enter A, and then enter B the same way. And then second quit. And then on the main screen, you hit, and then, to multiply. Oh, not B, it's supposed to be C, huh? Enter C. And then to multiply A times C. On the main screen, you go second matrix. You just stay on the names for A, and you hit enter. And then you go times, then you go second matrix, names, down to B, and hit enter. And then hit enter one more time. There it is. Somebody have a calculator I can create it on the big screen. So go ahead and enter A and enter B enter A and enter C like we did. Everybody got that down? Copying those steps down, and I'll go up to the main screen here. If you got that down. I'll flash back if you missed some of that. All right, so I'm on the thing here. So what's A is a what? A 2 by 3. 2 by 3. So I'm here. Let me quit the whole thing. So first you go second matrix. Second. Here's the matrix on the left. Right. It's the x to the -1 key. Second x to the -1. That goes into the matrix mode, at least on the TIs. Right. Go over twice to edit, and then you can edit. I'm on A, so I want to edit matrix. I hit enter. Then you do the size first, 2 by 3, 2 enter, 3 enter. Then put in the matrix A, which was what? 0, 6, -2. Is that what it is across the top? 0, 6, -2. Is that what it was? And what was the bottom? What is it? 1, 1, 5? 1, 1, 5. So there it is. I hit enter. 1, enter 1, enter 5, enter. They're entered. So every time you hit enter, remember it saves it. Saves it. So it's all saved. I just hit second quit. There we go. Now, back into matrix mode. You keep going in and out of matrix mode. Now, second matrix back in. Now, I'm going to go over to edit, but down to B. Everybody see that? No, or C. You could call it B. I'll go to C, I guess. All right, I'll go down to C. It doesn't matter what you call it. I'll go down to C. So second matrix, go over to edit and down to C. Everybody see that? And hit enter. And turn off the thing with your other hand. No. That's what it's in some funny mode now. It's in the, me and technology. Is that going to do something? It's like doing weird things. It's running auto scan, and there we go. Kinda. All right. So and then matrix C was a what? A 3 by 2. 3 down, 2 across, and it's what? 4, 1, 2, 2, 4, 1, 2, 2. I hit enter every time, and -6, 2, -6, 2. Good. So I entered matrix C. Everybody see that? 3 by 2. Second quit. So we keep entering stuff and then quitting, huh? Because it saves it every time I hit enter. Second quit. It's now got A and C in its memory banks. Here we go. Back into the matrix mode one more time. Second matrix. Names. That means call it forth, right? Name it. Say, come on down. Matrix A. Hit enter. There it is on the main screen. A. Times. I just hit the normal times key. Times. Then second matrix. Second matrix. And say, this time I want to name matrix C. I'm going to name C. Enter. There it is. A times C. Enter one more time. There's the same answer we got. It just did it by hand. Question? Are we good? Everybody got all that copied down? For multiplying two matrices, you can do that for adding, subtracting, multiplying numbers. You can do everything on the matrix, on the graphing calculator. We good? All right. All right, so here we are. Yeah, so the order matters when CA is not the same as AC. Now that we're not used to, right? With the numbers we're used to, multiplying two numbers never matters what order, right? 2 times 3 is the same as 3 times 2. They're both 6, right? That's called the commutative property of real numbers. They commute, they go back and forth. It doesn't matter what order. But for matrices, the commutative property does not hold, is how we say it. If you go to higher math, beyond calculus and stuff, you prove these kind of things. You take like systems of things, like and see, the matrix is a whole new world of things, right? And there's certain properties in the matrix world. And you learn whether certain worlds will allow commutative or not, or they'll do different things, It's not everything's just like you're used to in other kind of systems. Anyway, so that's the deal. I was just talking before class. The dean dropped by and brought her son by, who's going to Cal Poly, where I went. He's getting his master's in math like I did out there. And he's going to do some proof for people if you want to go by today's what's it called? What's the thing on campus today called? Showcase. That's it. Showcase. Anyway, so you can, some different departments are showing their stuff. So he's going to show a math proof anyway. Made me feel old. It's been 24 years since I've been to Cal Poly. I'm getting old. Anyway, he knew a couple of my professors still. They must be really old. Anyway, so, all right. So, so he's doing those kind of proofs right now, things like that. He loves that stuff, he was telling me. All right, so anyway, so those are not equal. So, and you know that, right? I don't need to prove that to you. Think about it. Matrix A, what's the size of matrix A? 2 by 3. What's the size of matrix C? 3 by 2. So we can do CA. Why? Because what's CA? CA is going to be a 3 by 2, and A is going to be a 2 by 3. Inside numbers match, so it's a go. The answer will be a 3 by 3. Sure enough, 3 by 3. Right? But can you do AC? What's the size of A again? 2 by 3. What's the size of C? 3 by 2. Oh, you can. Yeah, you can, but what's the size of the answer? 2 by 2, so it certainly can't equal CA because the answers are even different sizes, let alone the very same numbers. So there you go. You don't need any more proof than that. Clearly, the order matters in the matrix world, doesn't it? So remember that. That's going to come up and bite us probably Monday when we're going to do a certain property, and you'll tend to think, oh, it's just boom, because you're used to thinking in the system we're used to, where you can switch the order and it never matters. You kind of do it without even thinking, but you got to think about it. In the matrix world, order matters. Order matters when you multiply. In the matrix world, it is not commutative. You can't go back and forth. All right, AB plus 2I2. I remember taking a big matrix test. I took a whole class on it at Cal Poly. And I remember there was these big, like, 4x4, 5x5 matrices, all by hand. There was no graphing calculators we were able to use back in, I graduated in 93, so it's probably 92 or 91. Anyway, and I remember this big old 4x4, 5x5, something like that, matrix. There was like parts A, B, and C, and I messed up on one of the entries, added wrong or something, on like part A. And then I did part B and part C correctly, based on A though. It used A to do B and C. I remember the professor went slash, slash, slash. 0, 0, 0. I lost 30 points because I added one entry wrong. I always think about that when people think I'm harsh. I think, oh, you have no idea. I remember going out, really, Mr. Decline? I mean, just this one? He's like, yeah, those are wrong, Brett. Those are wrong. Like, okay. 30 points off my test grade. Yeah. So anyway, So what is I2? I2 is the 2 by 2 identity matrix, like that. That is the 1 in the matrix world. So that's what I mean. It's a different world, and different things do different things. That's what's called the unity element, or the 1. That's the big 1. At least that's the 2 by 2 one. There's an I3, which is a 3 by 3 one, like that. I'm not doing that very neatly. There's that's I sub 3. Those are all 1s. They all play the role of 1. Now, what do I mean, play the role of 1? Well, you tell me, what does 1 do in the real number system? 1 times anything is itself, right? That's what 1 does. We call that the identity element. The identity element. Meaning, why do we call it that? Because if you multiply by it, you get identical what you multiplied. Right? It gives you your identity. Right? If you take 7 times it, it gives you back 7. You take 10 times it, it gives you back 10. That's what 1 does, right? It's the identity element. That's what we generally call whoever plays the role of 1 in a math world. So in the world of matrices, these guys are the identity elements. Meaning, if you multiply any other matrix by them, you'll get back what you started with. That's what'll happen. You can prove it. I don't have time. I better move. I'm tempted. I want to, but I don't have time for that. But you can prove it. Take any matrix you want. Take this thing and multiply by the identity element, and you will get it. You'll get A back again. So it's the 1s down the diagonal, 0s everywhere else, always returns whatever you multiply it by. It's the identity. It plays the role of 1. All right, so with all that said, how can we do this problem quickly? Well, they're telling us to take A times B. So you could use your calculator, or you could do by hand A times B, and add to it 2 times the I2, right? That's 2I2, right? What does multiplying 2 by a whole matrix do? Where does that 2 go? Everything. Boom, 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 boom. So it'll become 2's down the diagonal, and still 0's, because 2 times 0 is still a 0. So whatever A times B comes out to be, and add that matrix is what they're saying. Does that make sense? You can just type the whole thing in your calculator, including the I2 if you want. Call that matrix C. Put 1s down the diagonal. Calculator can handle it all. You can do it by hand. Either way. Questions on that? Is that okay? Okay. Yeah, you can just do it in your calculator. Totally. I'll show you by hand, but yeah, go ahead and use calculator. So, all right. So we want the inverse now. Now, inverse in the real number system, what's the inverse of 7 in the real number system? And by that I mean the multiplicative inverse. It's 1/7, yeah. The additive inverse would be -7, but we're not doing that right now. We're doing the multiplicative. In other words, 7 times what would equal the identity element? That's what we're basically saying. 1/7, right? That's what an inverse is the thing times what would be 1, would be the identity element in that world. So anyway, inverses in the real number system, you just flip them. You know all about that. Well, how do you do the inverse of a whole matrix? What we're really asking is this matrix times what other matrix would equal the 1? That's what you're really asking, huh? Right? That's what it means to be an inverse. It's the thing times what would be 1. Anyway, I'm being too theoretical, Dave. Talking to the dean's son's got me all math theory today. Let me just show you how to get through these. So here's the steps. I'll show you by hand, and then you can just hit the buttons in the calculator also. Steps by hand for a 2 by 2 inverse. It's easy enough to do by hand. Step 1, so I'm going to call it A, B, C, D. That could be just like any 2 by 2. Switch the main diagonal. What do I mean by the main diagonal? A and D. This one. That's the main, because it starts with the very first entry. So we call it the main diagonal because it has the very first upper left corner entry in it. That's the main diagonal. The other diagonal is the secondary diagonal. So switch the main diagonal. Number 2, change the signs on the other diagonal. So you put the D here, the A there. You change this to -B and negative. So you don't move them. You just change their signs. Good so far? When I write negative b, you guys are starting to move on up into calculus and stuff. You want to start thinking this way. A less experienced algebra student would look at negative b and say, oh, that's negative. But you guys are becoming more experienced thinkers. You need to look at negative b and say, that's not necessarily negative, because b itself could be negative. That's the opposite of whatever b is. Think that way. That'll help you, especially when you get to calculus. You do absolute values, special things. You need to, if you keep thinking that means negative, you won't understand the logic. That means opposite, right? When it's on a letter, it means opposite, right? It might end up being positive if b itself was originally negative, right? It's the opposite of whatever b was. Think that way. That's true. All right, anyway, switch the main diagonal, change the signs on the other diagonal. Step 3, divide all 4 by what's called the determinant, which is AD, which is the number AD minus BC. So then you take all 4 of these and you divide them. All 4 by this number. And that number equals AD minus BC. There it is. There's the steps for doing a 2x2 inverse by hand. It's really pretty quick. It's probably quicker than using your calculator, actually. I'll show you. But you can do the calculator if you want to. Just switch the main, change the signs in the other, divide all 4 by the determinant, which is quick to figure out. So if you've got that copied down, I'll actually do it up here on this matrix. It's quicker than you might think.
The determinant is A times B minus B times
It's main diagonal minus other diagonal. Yeah, so grab these two. Whoop. Grab these two and switch them. So 1 goes here, minus 7 goes there. Good so far? I'm actually doing it now. So I switch the main diagonal, change the signs on the other diagonal. Let me make it a little bigger. Right, so switch the main diagonal. Change the signs on the other diagonal. See what I did there? You guys tracking with me? I'm doing the inverse. I switched the main diagonal. Changed the signs on the other diagonal. And then I'm going to divide. Let me make this smaller. I keep changing my mind on the side. 1 minus 7, negative 1, negative 1. Then I'm going to divide all 4 of them by a certain number. What is that number? The number is negative 7 times 1 minus 1 times 1, negative 8. Everybody see that? Can you read this here? Right? I did main diagonal minus other diagonal. That's the determinant. Right? Main diagonal minus other. Negative 7 times 1 minus 1 times 1. Negative 8. So divide all 4 of them by negative 8. Negative 8. Negative 8. Negative 8. Negative 8. There it is. That's the inverse matrix. You could simplify wherever there's 2 minuses, make a plus, but that's it, basically. Good? Yes, maybe I should do that. So cleaning up the signs, what do you got? Minus 1/8, positive 1/8, positive 1/8, positive 7/8. That's the inverse. Switch the main diagonal, change the signs on the other, divide them all by the determinant, which is main diagonal minus other diagonal. You can do it on your calculator, just put the matrix in and hit the x to the minus 1 key. On your calculator, it'll do the inverse for you automatically. I'll do it in a second when we get to a 3x3. We're not going to do those by hand. Is that good to there? Does everybody see how to do that by hand and able to get that by calculator? Only that, it kind of looks like it, huh? I scribbled it. That's supposed to be negative 1/8 there, huh? The rest are positive. Only that one came out negative. Good? Everybody got that all down? All right, so let's do that. All right, so let's do this one. So we've got 4, 5b. Can you find the inverse? Give it a go. So switch the main diagonal, change the signs on the other diagonal, and then divide all four by the determinant, which is main diagonal multiplied minus other diagonal multiplied. B here, 4 here. And the determinant, right? So everybody good so far? I switched the main diagonal. I changed, I didn't change the sign on that one, did I? I changed the sign on the other, both the signs on the other diagonal. And now the determinant is always main diagonal, 4b minus other diagonal, 5b. So the determinant is actually minus b, isn't it? Everybody see that? So divide all these by minus b. Is that making sense? Which can be simplified a little bit to be minus 1, positive 5 over b, positive 1, negative 4 over b. There's the inverse. Questions? So the inverse by hand, switch the main diagonal, change the signs on the other diagonal, divide all four by the determinant, which is main diagonal multiplied minus other diagonal multiplied. No questions? We good? Dad. All right. All right, so we will not do 3 by 3 inverses by hand. Instead, use the x to the minus 1 key on the graphing calculator. Yeah, so just type that whole matrix in, put it in matrix A, and then put A and hit the inverse button and hit equals. Somebody got it? What, am I going too quick? So just put that thing in and hit the inverse button.
-6, 6, 1.
You going across?
Yeah.
Okay.
7, -7, -1. 13, -13, -2.
Anybody else getting that?
Got it.
Same thing? Even the Casio can do it. No, Casios are good. Anyway, sent an email to my colleagues yesterday saying, why don't we go for Casios? They're cheaper. All right, so good. Just hit the inverse button and calculator. Tim.
Will you have to know how to do it by hand for higher math?
I don't know. Depends where you go, which take.
Math 6.
There's a lot of students that go in the Charleston that actually are doing it from higher up classes.
Really? What class are they from, Robert?
I see them from Math 6. I don't know if that's linear algebra or.
6 is third semester calculus. Calc 3, yeah.
And I think Math 28 and Math 7.
Calc 3, really?
That's terrible.
I don't remember Calc 3.
I'm not really sure exactly which courses they're in, but there's a lot.
I know it's not Calc 2 or Calc 1,
Yeah.
but maybe Calc 3 or linear.
I think it's a
For
little-
sure linear. Yeah, if you take linear algebra, yeah, because that's what this is all about. Is all improve things about it too. Yeah, no, you'll do all kinds of crazy stuff in there. All right, yeah. So if you want to go over it, I'd be glad to do it with you in my office. Come on by. All right, so. All right, so here we go. So we've only got 3 minutes left, so I'm going to do this quick. I'm not going to do it the way Math Excel says. I'm going to do a little even easier way. If you click on the help button, they're going to have you go through some steps, which are fine and good, and I might do it if I had time, but I don't. So I'm just going to tell you a real quick way. Just put the matrix in your calculator. Put the whole thing in, including the answers on the right. Everybody see what I'm doing? They're not going to show you this way. on the show me an example, but this will be a little quicker. Everybody see where that 0 came from? It's because this 5 really goes here, and the minus 4y there, and the 0's in the z column, you see. See that? And I put the answers in the matrix as well, and then hit R, R, E, F on your calculator. Did I show you that earlier? Oh yeah, I showed you that. You know that. We did that yesterday. Yeah, just do the R, R, E, F. There's another way where you take the matrix on the left and hit the inverse, and multiply by the matrix on the right as a 3 by 1 column matrix. That'll work too. It's quicker. So just hit R, R, E, F like we did yesterday. But notice, put the whole thing in, including the answer matrix, and the bottom row's got to be 5, negative 4, 0. Got to put a 0 in the z slot, right? That'll crank it out. Now, does this one come out weird? I want to show you about the infinite solutions, or I don't know if does this one come out weird?
1, 0, 0, 6, 0, 1, 0, 3, 0, 0, 1,
Oh, totally normal. Those are the 3 answers. All right. Yeah, other people got that? Same thing. Okay. I thought there might be a weird one. All right, let's. Because I wanted to show you that because there is one that might do something weird. So let's try this one. 2 minus 1, 4, 1. Minus 1, 2. Minus 4, 2. 9, 12, minus 4, 11. So put that whole thing in and do the RREF, reduced row echelon form. That's all those row operations that I showed you. That's what they're doing for that. So tell me, does that one come out weird? Yeah, if you get zeros all the way across on some row, it's going to be infinite. I want to show you about that. Is this one coming out with zeros? Oh, air? Kelton, what do you got?
1, 0, 4 thirds, 0. 1, there's 0, 1, negative 4 thirds, 0. 0, 0, 0, 1.
Oh, yeah. What does that mean right there? No solution. Right? When you remember me saying when you get all zeros in the number, remember because these are equal. Remember we put the right side was the equals. So it's still the same thing in the answer matrix. This means 0, 0 plus 0 plus 0 equals 1. No solution. So if you get a bunch of zeros and a 1, that's no solution. So your calculator just says error, huh, the Casio? Just says error. Okay. It's no solution. I wanted the infinite case, though.
Well, you could just turn the 1 right here into 0.
Yeah,
You're still
sure.
giving them the visual of it. Like you just show them
Well, no, there's a certain way they want you to type out the answer
Oh, yeah.
that I want to show. That's different than just saying infinite. I don't mean it just will say infinite.
It's the same as taking one of your equations.
Right. Yeah, you're right.